Welcome back to Stationeers, and it's time to build a better airlock. What's a better airlock, you might say? Well, one that actually works properly. Let's talk about what's going on. So I've got this gas sensor. It's over here in this block. I suppose I could put it one closer to the door, and I guess I could move this over this side. So we could probably get a little bit better out of this airlock to stop it from opening too soon. But I just want to be sure about it. I want to make sure we never lose any gas out of here. But furthermore, and if you're watching this much later after it came out, maybe the game already has this feature. But at the moment, the airlock always tries to pressurize to 101 kPa. I don't really want that. What I want to happen is either for it to try and pressurize to the same mats on the inside of the airlock, in there. It's 0 at the moment, but you get the idea. Or I can just say, hey, just skip that. We can just say, if we're going from outside to inside, from vacuum to, pressurize, we can just say, don't worry about actually pressurizing, just open the doors. It'll pressurize itself. Which one of those we go for, you can probably change yourself, depending on what your preference is. At high pressure, you might get thrown backwards into the airlock once you open the inner door, but, it'll still work, and hopefully it won't actually leak. So yeah, we've got to design a better airlock, and that's what I want to actually do. The other thing I'd like to do as well is, and this is maybe more on, I've not got any examples in my base, but if you have an airlock that's bigger, and I've been to a couple of other multiplayer servers where that's happened, there's been quite a bit of waiting when the airlock has started. So we probably want to build multiple active vents into here. And we probably want to eventually think about power saving as well. So we don't want it to consume lots and lots of electronics all the time, only when we want to, hopefully. So let's see, where do we start with that? Well, we can start with building a manually constructed airlock. I guess we can use these airlock doors if we want to, but I guess we can also build with glass doors. So let me go and find some bits and pieces and see what I can put together. Okay, so first thing is I've torn out the existing airlock completely. All the doors are gone. You can see the pipe, the wiring's still here, but all the walls and floors are gone. We've still got this APC, which isolates it from the rest of the network. That may be important later. I may have to move it just to keep all this nice and straightforward. And we may well build those up to put electronics on or something along those lines. We've obviously got our heating and cooling system for our base in here. It's on this wall. Yep. So we've got plenty of area that we could use for electronics if we wanted to. But let's just start with the basics, shall we? I've extended the size as well. I'm going to move, in fact, let me just put this passive vent on now. Hopefully it'll let me put it on. With that wall there. Maybe not. No. Okay, I'm going to need a wall. Just temporarily. Where's my welder gone? There we go. And let's get a wall. There we go. That's not where the welder goes. Okay, so we should be able to place the passive vent now. Yep. Okay. So passive vent as before inside the base. And then, we could also put down the doors, I guess. I think I'm going to go for glass doors. Hopefully they will be nice and nice and airtight. I'm sure we'll find out if not. But we can put them one on the outside. And we can spin that around and put one on the inside. And then, of course, we've got to extend these cables, which should not be hard at all. We can just use our knowledge of how cheap things are. If you just use four-way junctions and they're easier to place to get them connected. Let's just rotate you. And then that is a cable that I don't want to connect to. That is that's for the base, and it's not on this little mini network. So let's not connect there, shall we? Let's just avoid that. But otherwise, we can just go to straight cable. And probably some cutters for here. We don't actually need any of this cable anymore. At least we don't for now. There we go. Alright, so both the doors are now electrified. Should be able to open both of them. We can. And of course we can put the floor down as well if we wanted to. No real worry about that just yet. So if we wanted to create a manual airlock now, we could do. We just want to put an active vent right here, and we could just click on it, and it would work perfectly well. We just have to keep clicking on it when we wanted to leave, not necessarily when we wanted to enter. But that's okay. So that's step one. We've got a big airlock. So I've put some bits and pieces here in the airlock just so we can actually get a quick look at this active vent and what we can control. We have a few things here. Just 1 second. Let me need to cough. We can control them with a batch writer and control multiple vents like this. Now I may need more than one batch writer because we may need to control more than one attribute of the vents. We're going to want to control whether they're on and off if we want power saving. Otherwise, we don't need to worry about it. We are going to want to control whether... Well, wait, let's actually go and take a quick look. We can read the active vent, write the active vent, and we can write different settings. So the first one that we want to do is the on state. So it's hooked up to look at this via this dial at the moment. So I can just flip this dial and turn it on and off. Okay. We can also look at whether it's open. Don't much mind about that one. Mode. So the mode is the other switch. So we're changing that between inward and outward mode. So pump into the airlock, pump out of the airlock. There's also ability for us to set pressure external, pressure internal. Now, I assume because it's an active vent, you can pretty much tell it to compress or decompress to whatever you like. In our case, we're going to be telling it to compress whatever we want to charge our base to. That's one of the sort of improvements over the bare airlock that you get with the consoles. So that's pretty cool. And there's also another one as well. You can also do pressure internal. Not sure, can't remember which way around will be internal and external in this particular case. So, you know, we'll just try it once all the doors are closed. Much later on, though. We don't need to worry about it just for yet. But because we may need multiple batch writers to control each one of those things, then, you know, we're going to need room for that. I've also only put one active vent in place, although because I've extended the size of this airlock, what I might want to do is put 3, one for each block. And of course, you can choose however many you want to do in here. You could get 2, and then 2 on this side if you really wanted a really fast airlock. If indeed they work like that. Certainly, the regulators work better in parallel than just one on their own, or in series even. So we can carry on and see if we can construct a bit more. So for now, I've set up a simple way of doing a button. What we've got is a button to the outside, and this, with a switch, it's inherently sort of on or off, and you sort of have this weird thing of, well, you can see when it's on, and you can see when it's off, but you don't quite know what that means. So in the context of 2 different switches, that is. So, at least not without an XNOR gate. Anyway, so to keep things simple, I've got an outer exit button and an inner exit button. And what we'll probably do is have one out here as well, eventually, obviously, because we need to be able to get into this airlock and cycle it. But for now, we can keep it simple with the internal one. So an outer exit button, if I push this button, and let me just actually reset this now, because it's just going to change things. Oops, not 0.9. Set you to 0. Okay, so the default state is 0. If I push this button and let go, if I just use a writer to write to this memory, it's just a variable saying, hey, do we want to depressurize? Then as soon as I let go of this kind of button, it's going to flip back to 0, because this is going to read 0, which is going to read back to this again. So rather than having the more complex circuitry, just figuring out what I want from moment to moment, we're just going to set a variable in this memory unit. And I'm going to do that using a select unit, and very, very easy here. We take the outer exit button. If it's 0, we use the current value of depressurize. And if it's 1, we use its value. So if I push this button, it's going to set this to 1. It will stay 1. Nothing else will happen. Very, very simple. Nothing to worry about. It just means that I know, hey, is someone requesting that I depressurize? And that's what we're going to use for the rest of the circuitry. Now, an important point here, and a point which may not be immediately obvious, is that you don't want to do the same thing on the other side. We're actually going to... Let me just rename this, actually. It needs to be named something better. Airlock state. That's better. Okay, what you might think of doing is doing exactly the same on this side. So select unit, logic writer, and something that says pressurize, question mark. The problem with that is if you've got two people in here, or if someone goes and hits one button and then goes and hits the other button, and then you've got a logic memory that says, I want to depressurize, and another logic memory that says, I want to pressurize, you're going to have some problems. So rather than having to deal with sort of those in a complex way, let's simplify. And to do that, we're going to use the same bit of memory. But instead of having 0 and 1, we're going to have 0, 1, and 2. The airlock should only have so many states, and we can, infer what we should do based on the state. So let's say it's in 0, nothing happens. If we hit this and it turns to 1, then we should say, well, that means it wants us to depressurize, so we can read that with other things and do something. If, however, we hit this one, we don't want to change it back to 0, we want to change it to 2. Create an enum, if you like, if you are aware what one of those is. Essentially, this is going to increase by 1. Oops, increase by 1. And this is going to be 2. So now 2 means pressurize, please. And of course, we can have other states than those. So you could have more states. So you might imagine, well, if the outer airlock door is open and we're in the vacuum, well, the atmosphere equals the outside. We don't necessarily have to have vacuum on the outside, remember? We're doing things a little bit more complicated than the default airlock. So we can say, okay, so that's state 0. State 1 might be, well, the outer airlock, both doors are shut, but nothing's happening. Then you could have 1 that is, it's in the same thing, it's depressurizing, the same thing, it's repressurizing, or then like the inner door is open. Not quite too sure just yet what we're actually going to do for that kind of thing, but that's the idea. We want some kind of state of what the airlock is currently in. Okay, so for the interior door, we can, it's similar circuitry to the exterior door. The only thing is, because this is the first state we put in, we can flip between 0 and 1 here, so we get an implicit 1. Here we need to get a 2, so you could use a math unit if you wanted to, but I've just set an actual variable called I pressurize. Technically, if you wanted to do it properly, I suppose you could put an I depressurize here set to 1, and then you do the same circuitry on both sides. But in our case, we're not. It's just easier not to have one of these extra things using up resources. So we'll have an inner exit button. We'll look at the inner exit button, and if that is 0, we'll leave the value to airlock state. But if it is 1, if we push the button, we're going to have a value on this of whatever I pressurize is, which is set to 2. So if I push the button, you'll see it goes to 2 and back to 0. So then we take that into our input. What's this called again? Inner door select. There we go. And we're going to set that to be whatever the setting of airlock state. Is that going to cause a problem? So 0. That's set to 1. Okay. Yep, and that's currently set to 1. If I push this, it should set it to 2. And back to 1. Yeah, so now we've got a nice bit of circuitry set up. So, of course, nothing's going to set it back to 0, even if both of these are set to 0, which they currently are. That's 0. That's 0. We've just got this nice little indicator of what we want to do with the airlock next, or what we're requesting as a user. Okay, so let's move on to the next part of this. We're going to want to close the doors, and currently both are open, but that'll never happen in practice. One of them is going to be open, one of them is going to be shut. So we're going to have to deal with some way of closing them both. If only we'd had an episode recently where I went through Boolean logic. So what we're going to do is add both buttons together, okay? Outer exit button, inner exit button, and we'll be able to chain more of this later if we have more buttons. We're going to add them. And then we're going to do a select. Is it select? Compare, sorry. Yes, compare. So let's put you down. And I'm probably going to need logic memory as well. Let's just put you up here, shall we? And that's the wrong way up. Not that it matters. But let's leave that 0. So if we just rename you to 0, 0. There we go. So what we're then going to do is, first of all, let's turn you on. Let me just change back over to my screwdriver. Turn you on. You're currently both set to 0. There's no power yet. That's why I need to connect you to power, which just means a little bit of cable right there. There we go. So add them together. And then we're going to call this, I don't know, doors or something like that. Doors or. Then with this compare unit, we're going to compare doors or. Once we select it. There we go. With 0. So is it greater than 0? 0 is in here somewhere. There we go. Are you greater than 0? Right now you aren't. Okay, just to close off the episode, I'm just going to complete this circuitry. So let me just pop this in place and get my cutters. This is unfortunately going to have to be a multi-part episode. There's far too much circuitry to really deal with this in one episode. You'll see what all the rest of this is doing in just a second. It's doing actually some quite simple stuff, but the this whole circuit by itself is not actually the least complicated thing in the world. So let's quickly review in a second. Put you back in here. And I need the screwdriver, and yeah, let's actually review. So we've got 2 buttons. Either button is going to latch this state for the airlock above 0. It's currently 2, but it doesn't really matter. That will be set to 0, and you know we're going to push a button, and the doors are going to shut. We'll see why in a second. I'm going to set the airlock to a certain state. Same thing on this, except it's going to set a state to 2. No difference. Nothing else happens to the doors. Exactly what we want. All right, now this OR, which is just taking the input of 2 buttons at the moment. We'll have to change it once we get to 4 buttons, but don't worry, we'll get to 2 buttons to start off with. So yeah, we're going to take this OR. We're going to compare it, see if it's greater than 0. I.e., has either button been pushed? And it also guards against, has both buttons been pushed? If you've got 2 people in this airlock and they're both jamming the buttons at the same time, yeah, we want to do something sensible. So we then take that and we have another sort of state like this, except this one is only 0 and 1. We're going to take in shut doors complete, which is this, compare even. And if it turns 1, we're going to output. So straight through. If it's 0, we're going to reuse this same value, just like we have done here. Okay, and this writer, all that it does is take this and output it to there. If it's, you know, there we go. See, it's taking that and pushing it to that value. So request to shut the doors. Let me just actually reset that down to, yeah, because it needs to be done manually at the moment. So if one door is open, we've got request to shut doors. We've got airlock state is in 2, but in fact, let's bring that down as well. Decrease to 0. These are independent of each other. So it doesn't matter what this is, it's not going to affect the doors. This will affect the doors. So what we then have to do is read in the individual values for the doors. So we have to read is the inner door open? So inner door open state and outer door open state. Now you'd think, well, can't you just set a batch writer and use that request to shut doors and modify it somehow to just shut both doors? That would be more efficient, wouldn't it? Yes, but the problem is there that we have to do a calculation based on the door, whether the door is open or shut. And if in an airlock, both doors can be shut, or one can be shut, or the other can be shut, and it gets a bit more complicated. So it's a bit easier to think about it if we assess them independently. So we read in both the values. We take a math unit and we subtract from those current values, which is at the moment inner door is 1. So we subtract this request to shut doors. Okay. Then we write that back to the door. So the inner door, it's open state. and we read it in from here. So if I turn on the request to shut the doors, this is going to be 1 minus, if it's open that is, it's going to be 1 minus 1, 0. The writer is going to say, okay, write 0 to this door, and it's going to shut. Same thing's going to happen over here when I turn it on and configure it. I'll do that between the episodes. So what happens then if the door is already shut? It's going to be 0. And 0 minus 1, it's going to turn into -1, which is effectively junk as far as the door's concerned. It's not going to do anything different. So the writer will just write -1 or try to write -. In fact, let's actually have a look at that. What happens? Let's push this one and let's see what happens. So the door's going to shut. Airlock state is 1, or depressurizing, you know. This is request to shut doors is set to 1. We'll change that via another circuit once we've depressurized. At the moment it's manual. So the logic writer is -1. So it's trying to write -1 to the door. The door doesn't care what -1 is. I mean, you could put a min-max in here if you wanted to, but there's no need, and it takes power, so we may as well not. And we're going to have the same thing here as well. This again is going to read the current value of the door, subtract the request to shut the doors, and then write it back out. So it doesn't matter which button we push, it's going to shut both doors and lock us in here. And then we're going to need to do something and respond to that. So what we're probably going to need to do is look at this state and make sure, I guess, that that is 1 as well. And then we're going to do something to start pressurization up once they've both changed. We may need to delay though, although I'm not sure whether we should or not. If we start it up too soon, it may well try to depressurize or repressurize before the doors are actually shut. So we may need to, or I guess we could just read both of these, and we could do we could combine them. And what do we want? We want to make sure it's always 0. So yeah, we add them together with an and you know, evaluate equals 0. And if that means both doors are shut, okay, or yeah, we could just do a math unit or some probably on this wall. If both doors are shut and this is set to 1, then we can then start depressurization or repressurization in the case of 2. Yeah. So that's going to be next episode. Hopefully you enjoyed this one. I know it's quite complex, and I know that there's a lot of power being sucked out of our main system here. We have power to spare, and we're going to get some power savings for this. We'll turn the whole thing off when it isn't in use, etc., if we can do anyway. And so it may even be a 3-part episode. I think next episode I'm going to carry on, do the depressurization and repressurization bit, and then the one after, maybe some final bits and pieces of, you know, power saving. It depends how long it takes. I don't want to take too much longer than half an hour for all of you guys. And yeah, I hope you enjoyed it. I know you can make your airlock yourself very easily with a console. I know. I know. Okay, but this will allow me to then feed in more things. It will allow me to feed in gas sensors, inside, outside, inside the base. It will let me do things such as I mentioned, I think at the start of the video, if I want to pressurize to a certain amount, I will be able to. Or if I want to pressurize to whatever it currently is inside, i.e. the time to pressurize will be as short as it can be without any difference in pressure when the door opens, we can do that as well. And we can also make sure that we don't have any air lost out through the doors. So instead of setting this to sense on gas pressure, we could instead time it for this particular space, add more active vents as need be, and then just have a timer running. So as soon as it starts a depressurized thing, it basically just clicks on a timer to say 4 seconds, boom, it's all gone, close off, and open the outer door. So hopefully you join me for the next episode. Or you'll run screaming at the horror of all this electronics. But for now, this has been this episode. Feel free to thumbs up, subscribe and share as normal. And yeah, we'll see you next time. Thanks for watching.